Welcome everyone. Today I'll be solving question number 51 of the 2023 GATE Biotechnology paper. The question is that if there are three unrooted trees for four protein sequences, then the number of rooted trees for the same number of sequences is. So first, let's understand what is meant by rooted and unrooted trees. So in phylogenetic trees, there are two types. One is rooted and one is unrooted. A rooted phylogenetic tree shows the last common ancestor of the group. All these are rooted because they are showing you the last common ancestor of the group of organisms, that is A, B, C, D, and E. And what is shown to you in the middle is the unrooted phylogenetic tree, where it shows the relationship between the organisms but without showing the common ancestor. There is a formula for finding out the unrooted and the rooted trees that can be formed from a certain number of sequences provided to you. For an unrooted tree, the formula is 2n minus 5 double factorial. For a rooted tree, it is 2n minus 3 double factorial, where n is the number of sequences. What it means when you say a double factorial is, or how it is different from single factorial is. So, if it was 5 single factorial, then that would mean you multiply 5 into 4, which is multiplied into 3, into 2, and into 1, right? When you say 5 double factorial, what you have is 5, you ignore the 4, then you move on to 3, you ignore the 2, and then you move on to 1. So that means the answer would be 15, right? So for this case, what this saying is that if there are 3 unrooted phylogenetic trees for 4 sequences, that is n is given as 4, you have to find out the number of rooted trees. They've given you the amount of unrooted trees and they've also given you the number of sequences. So this is what we actually need for this. So if you know the formula for rooted trees, that is 2n minus 3 double factorial, and n in this case is 4, that means 2 into 4 minus 3 double factorial. So it is 8 minus 3 double factorial, that is 5 double factorial. And as I showed you last time, 5 double factorial is 50. So that means there are 15 rooted trees that can be formed from 4 sequences. That's the answer for this. I hope that was easy for you to understand. Thank you so much for listening.